Okay, this video is going to be talking about the theorems about roots and the fundamental theorem of algebra. Okay, so rational root theorem basically states a way to determine whether something is a possible root. We're going to use the equation P over Q, where P is a factor of the constant term in the back end of the equation and Q is a leading coefficient, so the number in the front end of the equation. And it will give us our possible answers that could be roots. So on the top, we are going to do factors of my coefficients of 6 over factors of my number in front, my leading coefficient, which is 1. Remember, whenever we're doing factors, we need to include the positive and negative sides of it, because we could have negative 2 times negative 3 give me 6. So I'm just going to put a plus or minus out front here, so factors of 6. Then our 1, 2, 3, and 6, and then factors of 1 would just be 1. So all my possible answers are now what's being divided. So if I do my possible roots here, 1 divided by 1, first we need to include the plus or minus of it. 1 divided by 1 is 1, then I do 2 divided by 1, which is 2, 3 divided by 1, which is 3, 6 divided by 1, which is 6. So there's my all my possible roots. So now when I do my other one, we're going to do my factors of 2 over my factors of 3. So we need to include the positive and negative side, so I got 1 and 2 on top and 1 and 3 on bottom. So my possible roots are 1 divided by 1, which is plus or minus, 1 divided by 1, which is 1, 1 divided by 3, which is 1/3, 2 divided by 1, which is 2, and then 2 divided by 3, so 2 over 3. So there are my possible answers that could cross my x-axis if I were to factor it or graph it. Okay, so I'm going to do factors of 12 over my factors of 4. So I need to include the positive and negative side of it. So I got 1, 2, 3, 4, 6, 12, and 1, 2, and 4. Okay, so my possible answers this time are going to be 1 divided by plus or minus. 1 divided by 1 is 1. 1 divided by 2 is 1 over 2. 1 divided by 4 is 1 over 4. Then we go with 2. So I got 2. 2 divided by 2, I already have 1, so I don't need to rewrite it. And then 2 over 4 is the same thing as 1/2, which I already have. So then we start with 3. So I got 3. Got 3 over 2 and 3 over 4. Then we do 4, so 4. 4 over 2 is 2, simplified, so I don't need that. 4 divided by 4 is then 1, so I already have that. Then I got 6. 6 divided by 2 is 3, which I already have. 6 over 4 simplified to 3 over 2, which I already have. So then I do 12, and then 12 divided by 2, which is 6, which I already have, and 12 divided by 4, which is 3, I already have. So these are all my possible answers that will be roots to this equation. Okay, so this one we're going to do factors of 21 over factors of 1. So I got 1 plus or minus 1, 3, 7, and 21 over 1. So my possible roots are going to be plus or minus 1, 3, 7, and 21, because all those divided by 1 are just themselves. So now I need to go and I need to test to figure out which one of these is an actual root that if I graphed it, it would cross my x-axis. So what I'm going to do is I'm going to use synthetic division. So I go 1, 2, 4, and 21, because they're all written in order, and then we're just going to pick one and test it to see if it works. So right now my possibles are positive 1, negative 1, positive 3, negative 3, positive 7, negative 7, positive 21, negative 21. So let's say we pick 1. So remember, we always drop the first one, we multiply outside, add inside, so 1 times 1 is 1. And add inside, so 2 plus 1 is 3, multiply outside, add inside, multiply outside, That does not give me 0 here. That gives me a remainder. So I need to pick a different number that's not going to give me a remainder right there. So let's try another one. Let's try a negative, and let's try a 3, because I need to somehow get this to 21. So when we multiply on the outside, add in the middle, multiply on the outside. Okay, so that one gave me a remainder of 0. So if I rewrote this, it was x cubed, so we bumped down 1. So now it's x squared minus x plus 7 with the one I just did. So there is a possible root to be able to be factored, and sometimes you can factor this more. Okay, my next one, we're doing factors of 5 and factors of 1, so plus or minus 1 and 5 and 1. So my possible roots are going to be plus or minus 1 and 5. So I got 1, 5, 1, 5. Let's go ahead and try negative 5, because I know I need a negative for it to cancel. So I'm going to drop my 1, multiply, add, multiply, add, multiply, add. So it looks like I get the remainder of 0. So it was x cubed, I jumped down to x squared plus 0x plus x, because that 1's in front of the x, and then the x plus 5 on the outside. So if I simplified this, that's x squared. Oops, that's a plus 1 right there. Plus 1. There we go. And then x plus 5. Okay, my next one, I'm going to do factors of negative 4 and factors of 2. So we're still going to have the plus or minus side because I still need positives and negatives to get me to negative 4. So it's going to be 1, 2, and 4 on top, and then 1 and 2 on bottom. So my possible roots are going to be, and then we got 2 divided by 2, 1 over 2. We got 4. 4 over 2 is the same thing as 2. So there are my possible roots this time. So when I do my synthetic, I got 2, 7, negative 5, negative 4. This time, let's go ahead and try negative 4. So I drop my 2, multiply on the outside, add on the inside, multiply, add, add. So this one becomes 2x squared minus x minus 1, and then x plus 4. And then you're possibly able to refactor this, in which case you'd send your 2 back. You see what multiplies to get you the outside, adds to get you the middle. With these, an easy way to check to see what this number is going to be really quickly is if you put this in your graphing calculator and graph it, it will literally show you that it crosses your x-axis at negative 4, in which case that will automatically be a root that you can use, which is how I'm finding all these without guessing and checking, to be able to use the synthetic division to break it down a lot quicker instead of guess and check. Okay, conjugate root theorem basically states that p of x is a polynomial with rational coefficients, then the irrational ones, so anytime you have a square root or an imaginary, we have the conjugate of it. Okay, so this includes square roots and complex. So 3 plus 4i has the 3 minus 4i, so we always flip the sign. It comes in pairs. So it only happens when you have a square root and imaginary. I don't care if it's a real number. So this I need a 1 plus I. This I need a negative 2 minus the square root 11 and a negative 4 plus 6i. You only flip the thing that has the square root in the imaginary. This becomes 5 minus the square root of 3, positive square root of 2. This becomes a positive 3i and a negative 7i. So you just flip the thing that has the imaginary or the square root attached to it. Okay, write the polynomial with the given roots in standard form. So ax squared plus bx plus c. So I give you the roots. Remember, whenever you plug them in, you always plug them in the opposite of what I gave you. So then you would FOIL. First is x squared, O is outside, I is inside, and then L is last. And then we simplify to get y equals x squared minus 17x plus 70. My next one, I have to include the conjugate, so I need x plus 3, I need x plus 5i, and I need x minus 5i. And remember, my shortcut for this is I always pick the ones that are the same number, one positive, one negative, and I eliminate those first. So when I do that, I get first, outside, inside, and last. I'm going to change my I squared to a -1, and then I'm going to cancel those out because they're the same things. So if this changed to a -1, negative 25 times -1 is a positive 25, and then I just have to FOIL again. So F stands for first, so I got x. So x times x squared gets me x cubed, and then first, so now we do outside, so plus 25x, inside 3 times x squared gets me 3x squared, and last 3 times 25 is 75, and then we make sure, since it needs to be in standard form, we put it in standard form, so x cubed, then x squared, then 25x plus 75. Okay, write a polynomial function with the given roots. Remember, we always have to do the conjugate of this, and we need to have x's in it. So I have x minus the opposite. So right now it's a positive 6, so we're going to do, let me zoom in here, y equals x minus 6 minus I. So the regular version, and x minus 6 plus I, because you got to do the conjugate of the I. And we have 2 trinomials this time, so we're going to have to distribute, and it's going to be really long. So I'm going to distribute my x first. So x times x gets me x squared. This gets me negative 6x. To my last term, I got plus ix. Now I do my negative 6, so I'll change colors here. Negative 6 times x gets me negative 6x. Negative 6 times negative 6 is 36. And negative 6 times I is negative 6i. And now I got to do my last set. So I times negative x is negative ix. I times negative I times negative 6 is a positive 6i. And then my last negative I times I is negative I squared, okay? So remember, you always have to have the x's, and since it was a positive 6, when we put it in the parentheses, we switch it to minus 6. And we need to do the conjugate. So I need a negative I and a positive I when I put it in. Now let's go ahead and combine like terms and cancel some things out. So it looks like I have positive ix and a negative, so they cancel. And then I have a negative 6i and a positive 6i, so they'll cancel. We got to combine like terms. So I got y equals x squared, negative 6x minus 6x is negative 12x, plus 36. I can change my I squared to a -1. So that changes to a plus 1, so y equals x squared minus 12x plus 37. And it is in standard form. Okay, so my next one, I need to make sure I include my x, so I got my parentheses x minus, because we do the opposite of the 3, my regular one, and then x minus the 3 and the conjugate of it. So we flip the I. We're going to distribute in, so I distribute my x first. X times x is x squared, minus 3x minus ix, or xi, means the same thing. Negative 3x. Negative 3 times negative 3 is positive 9. Negative 3 times negative I is a positive 3i. And now I got to do my last set. I times x is ix, or xi, means the same thing. This gets me negative 3i and minus I squared. So let's go ahead and cancel some things. So negative ix and ix canceled. Positive 3i and negative 3i. And then we can combine like terms. Negative 3x minus 3x is negative 6x plus 9. I can change my I squared to a -1, which will change to a +1. So when we add it, we get y equals x squared minus 6x plus 10. And it's in standard form, highest exponent to lowest. Okay, fundamental theorem of algebra. The degree of the equation tells us how many roots there are. This includes real and imaginary, which is complex. So we're going to factor. So this 4 tells me how many answers I should have, including real answers and imaginary. So I should have 4 answers when I do this. So what multiplies to get me -3 adds to get me 2, because there is no GCF and no number to send back. So that is going to be 3 and -1. So I get x plus 3, x minus 1. But if I did ZPP right now, I'd only get 2 answers. To get x to the fourth, I need to add squareds. So now when I do ZPP, I have x squared plus 3 equals 0, x squared minus 1 equals 0. Add 1, so x squared equals 1. Opposite of squaring is square rooting. When I take the square root of a number, I need to include positive and negative. Square root of 1 is 1. Subtract 3 for this one. Opposite of squaring is square rooting. My answer should include positive and negatives. How do I get a negative out of square root? We add an imaginary. And I can't break the square root of 3 down any further. So I have plus or minus I square root of 3 and plus or minus 1. So there are my 4 answers, the positives and negatives of both. Okay, find the number of roots for each equation. So the number of roots for this one, we got 5. If we want to factor it all the way down to find the roots, okay, first we're going to do synthetic division. So if I want to do my synthetic, I got to find the factors of my back end, so 4, and my factors of my front end, so 1. So plus or minus 1, 2, and 4 on top, and 1 on bottom. So if I were to graph this, plug it into my calculator, I'll notice that it crosses my x-axis at 1, so I'm going to go ahead and try that root. Put my numbers in, I go x to the 5th, to the 4th, to the 3rd, squared, the regular, and my constant. So I don't need to fill in any zeros because I go in standard form and I don't skip an x. We just drop the 1, multiply on the outside, add on the inside, multiply on the outside, add on the inside, multiply on the outside, add down, multiply, add again. I went from x to the 5th, and then I divided one x out, so I'm going to start with x to the 4th. So I got 1x to the 4th plus 0x cubed minus 3x squared plus 0x minus 4, and there was no remainder. But I need to put what I was trying to divide. So remember, whenever we put it into the set of parentheses, we always do the opposite, so it's going to be x minus 1. That 1 came over here now. So let's go ahead and simplify. So I got x to the 4th, that went away, that went away. So we got something like this. So we're going to try to factor this now. Okay, so it still said equal to 0, so what we can find our zeros. So what multiplies to get me negative 4 adds to get me negative 3. That's going to be negative 4 and 1. But I need x to the 4th, so I need to make sure when I do this, I got x squared minus 4, x squared, oop, I'm going to erase that and scoot it over, x squared minus 4, x squared plus 1, and then I still got my x minus 1, so now I can do my ZPP. I said x squared minus 4 equals 0, x squared plus 1 equals 0, and x minus 1 equals 0. So the last one's pretty easy to solve. You just add 1. So I got x is equal to 1. This one we subtract 1. Opposite of squaring is square rooting. I need a plus or minus in my answer. To get rid of my negative, I put an imaginary, so then it becomes the square root of 1, which is just 1, so we can keep it just I. Then we're going to add 4, so x squared equals 4. Opposite of squaring is square rooting. Square root of 4 is plus or minus 2, so I have positive 2, negative 2, positive I, negative I, and 1, which totals for 5 answers, which is what it was. Okay, my next one looks like I should get 4 answers this time. Okay, so if I were to plug it into my graphing calculator, I could see that negative 5 is crossing at the x-axis, so I go from x to the 4th to x cubed to negative x squared to x to no constant, so I need to put a 0 in there. So I'm going to drop my 1, multiply on the outside to get negative 5, add down to get negative 3, multiply on the outside to get 15, add down to get 2, multiply on the outside to get negative 10, add down to get 0, multiply on the outside to get 0, add down to get 0. So I don't have a remainder. I went from x to the 4th. If I take an x out, I start with x cubed, so I got x cubed minus 3x squared plus 2x plus 0, and then I have to include my x plus 5 on the outside. Remember, when we put it in a set of parentheses, we flip it. So if I rewrote that a little simplified, so now let's see if we can keep factoring this. I first check to see if there's a GCF, and there is. It is x. So if I rewrite this over here, I got x cubed minus 3x squared plus 2x times x plus 5. So we divide the x out. It goes in the front, doesn't just disappear. So now it becomes x squared minus 3x plus 2 times x plus 5. And this is still all equal to 0. I can't really fit that in there. Okay, so what multiplies to get me 2 adds to get me negative 3. It's negative 2 and negative 1. So I got x minus 2, x minus 1, x plus 5 equals 0. So when I do ZPP, I got x is equal to 0. When I set x minus 2 equal to 0, I add 2 to both sides, so I get x is equal to 2. X minus 1 equal to 0, we'd add 1 to both sides, so I get x is equal to 1. And x plus 5 equals 0, we'd subtract 5 from both sides, so x is equal to negative 5, for a total of 4 answers, which is how many I wanted.